We are going to discuss Freivalds algorithm today. Freivalds algorithm is a randomized algorithm. It is used for matrix multiplication. So this algorithm is a very popular algorithm so Freivalds algorithm names after Racine Martin's Freivalds, and it is a probabilistic randomized algorithm used to verify matrix multiplication. What is the basic concept of this algorithm is that given three n cross n matrices A, B, C, a general problem is to verify whether A cross B equal to C. That means if you multiply two matrices and the resulting outcome also will be matrix. So Freivalds algorithm basically verify that, and it also reduces the time complexity. And if you see the history of matrix multiplication, so we have the naive matrix multiplication concept, which takes theta n cube time. So you can see that here we have a matrix multiplication situation where we are multiplying this matrix and these two matrices we are multiplying and we are getting the results. So this matrix multiplication requires three for loops to implement entries. So afterwards what happens, we have discussed divide and conquer strategy. In divide and conquer strategy we have seen transcend matrix multiplication, which for which the time complexity is big O of n to the power 2.807, which is somewhat better than the earlier naive simple matrix multiplication, which takes theta n cube. So this is big O of n square, big O of n to the power 2.807. This is transcend matrix multiplication, which uses divide and conquer method. Next we have Coppersmith and Winograd strategy for matrix multiplication. This strategy it takes time around big O n to the power 2.376, and this algorithm has been developed in the year 1989. And the most recent one is Williams, which is the improved version of matrix multiplication, which takes around n to the power 2.3729, and that has happened in 2011. So this is the history of matrix multiplication, and you are seeing that how the time complexity is gradually improved. Now the Freivalds algorithm is quite a different thing. It is a randomized algorithm. So randomization technique is used. Randomization technique means it's a probabilistic technique. So whenever this probabilistic technique comes, so you have these random values, okay? So the basic idea of this algorithm is that you will be having again three matrices. So input will be three n cross n matrices. So matrix A, matrix B and matrix C. So we'll multiply matrix A with matrix B. So this is our matrix A, this is our matrix B, and the resulting matrix in C. So this algorithm will verify this. So all the matrix, their order is n cross n, B matrix order also n cross n, C matrix order also n cross n. So output will be, so if this algorithm what it will do, it will output yes if A cross B equal to C, and it will output no if A cross B equal to not equal to C. So what is the procedure to do that? To get the output yes and output no, do that using Freivalds technique, what we are going to do, we are going to generate one n cross 1 random 0 1 vector, which we'll call vector R. Okay. So this vector R will be intentionally added in both sides of the multiplication. That means, so we are going to calculate A, matrix A, and then you have matrix B, n cross n matrix. With that we are going to multiply this matrix R, which is a a random vector, which is a random vector. Okay, so this matrix we are going to multiply. So this is our matrix R. So this is n cross n, matrix A, matrix B also n cross n, and matrix R. However, the order of the matrix R is n cross 1. And the resultant and the output will be what? Output will be already C was the output earlier, matrix C, which is of n cross n order. With that, this side, that means in the right side also, we are going to introduce this matrix R, which is a random vector. This also will be order of n cross 1, n cross 1. So this is like a random vector R1, R2, R3, Rn. That means n number of random values will be here. Similarly, here also R1, R2, dot 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 Rn. And this is A, matrix A, this is matrix B, and this is matrix R. That means we are going to introduce a random vector, which is also a matrix, but the order is n cross n. So the output, if you see the output for this side, left hand side, the output will be, this side output will be how much? This side output will be n cross 1. This side also output will be n cross 1. Why it is so? Okay, so I'll tell you why it is like that. So if you see this one, this is my matrix A, which is of n cross n, and this is of matrix B, which is of also n cross n, and then finally you have matrix R, which is a vector, order is n cross 1. So this algorithm will try to exploit the randomness that vector R, matrix R introduced, which is R1, R2, like that. So carefully, if you see, if you multiply these two matrices first, so what will be the order of this matrix? The resulting matrix order will be n cross 1 only. Okay, so n cross 1. So this the multiplication of B and matrix R will be n cross 1. Order will be n cross 1. With that, if you multiply matrix A, whose order is n cross n, similarly you will be getting a resultant matrix of n cross 1. So what is the time complexity? See, matrix B is this one, which is having n number of elements here. Okay, matrix B, let's say B11, B12, like that, B1n. With that, if you multiply R1, R2, Rn, whose order is n cross 1. So for each of these B11, B12, so multiplying this R1 with this B12, B11, B12, B13 and B1n, you need total On time. Because n number of entries are there in this matrix B, let's say this is matrix B. With that, if you multiply this matrix R, so total for n number of entries for this one element you have On. For there are n number of random numbers are there in this matrix R. So for n number of elements, random numbers, you will be having On square time. Okay. Similarly, this resulting matrix, which is nothing but multiplication of B into R, that is also a matrix only. Its order is again n cross 1. With this, if you multiply A, whose order is n cross n, this is my matrix A, and this is nothing but BR. So again you will get time complexity will be On square. So you can see that considerably the time complexity has been reduced, and it is now big O of n square. Just that you have multiply one matrix which is in random in nature, and the order is n cross 1. The time complexity has been reduced considerably, and now it is On square. That means randomization actually reducing the time complexity of multiplying two matrices. But this is not the end. A cross B equal to C, then algorithm returns yes, which is true. That means if A cross B equal to C, and if it is yes, then algorithm is always true, algorithm is always correct. Okay. then the probability that the algorithm return yes is less than or equal to 1/2. That is called one-sided error. Okay. And by iterating the algorithm k times, returning yes only if all iteration yield yes, a runtime of kn square, and error probability will be less than equal to 1 by 2 to the power k. That will be achieved. That means when the algorithm is a cross b equal to say c, it is yes, then the algorithm is correct. That is not an issue. But when a cross b, which is not equal to c, so a cross b equal to c, algorithm says yes, that is fine. But when a cross b is not equal to c, then what is the probability? How the algorithm, I mean, when a cross b not equal to c, that time algorithm will reply, algorithm will results yes, that probability is very less. That probability is very less. So what may happen? Let's say if you multiply the r vector, which is completely zeros, the r vector that you are multiplying is completely zeros, and if you multiply this with the b and then finally if you multiply with a, so this side it is 0 and this side you are multiplying the result with c and then r vector is 0, that side also 0, so 0 0, both sides are 0 0. So but that is not what we want. Okay, so basically a cross b, when it is not equal to c, that time there should be a bound of the, I mean the probability should be bounded. So the probability should not be too high. That occasion should not happen too many times when a cross b is not equal to c. If you can prove that, then we can say that the introduction of these random values or random numbers in terms of n cross 1 matrix that we are multiplying in both sides, it's meaningful. Otherwise, why should we use this randomized algorithm? Because it will not give correct answer when a cross b is not equal to c, because it is all about random values, right? Random values can be anything, like it can be 0 0 0 entries. Some entries should be 0, some entries should be 1, maybe 1, that you don't know. But there will be, so basically this r vector that we are dealing with, this r vector that we are multiplying with b first and then finally you are multiplying with a, this r vector, we have to be careful with this r vector, because there will be some bad r's which will cause this multiplication a cross b not equal to c. Okay, so this is the problem. So let's take one example, then we'll understand it easily. So let's take, we have two matrices, the order is 2 cross 2. So this is matrix A, this is matrix B, and this is matrix C. Okay, so this is fine, this answer is matching up, I guess. And a two random element vector with the entry 0 or 1 is selected. So this matrix R, basically this is my matrix A, this is my matrix B, and this random matrix that I am taking, which is of n cross 1, that means 2 cross 1, that means 2, the row entries will be 2 and column entries will be 1 column and 2 rows. So these we are choosing randomly, which is 1 and 1. Okay, and let us see how this algorithm behaves. So this calculation happens, how this calculation, so this is my random r vector matrix, this is my A, this is my B. So A is 2 3 3 4 and my B is 1 0 and 1 2. Okay, and my R is this. So what we are going to do, we are going to calculate A into B into R first minus CR. Okay, and let's say if the multiplication has happened correctly, then AB R minus CR should result 0. In fact, if you multiply two matrix AB which is equal to C, if the multiplication is correct, then AB minus C should be equal to 0. So here also ABR minus CR should be equal to 0. So you see here, A, first we are multiplying B into R minus CR. So this whole thing, if you multiply correctly, you will get a 0 results, right? So in this case, my random vector, the random matrix that I am introducing here, which is of 1 1. So we get correct result. So this is correct. This time the result is correct. When result is correct, in spite of introducing a random vector here, result is correct. Next time, the random vector that we are choosing here is something like this, 1 0. Okay, 1 0. So how many ways you can choose? How many ways you can choose the random vector? 2 cross 2. So I can have these combinations. I can either choose 0 0, which is a completely zero vector. Okay, and I can choose 0 1. This is non-zero vector. Let's call it non-zero. Not all are zero. And then 1 0 also I can take, as we are talking about R. And then similarly, finally I can have 1 1, which is also non-zero. These are all non-zeros. So this time we are taking 1 0, these combinations where zero value is there. Okay, random, because this is a random vector, so any values of 0, this is random bits actually, so bits either could be 0 or could be 1. Okay, and these bits are independent. There is no relationship that this one should be related with this 0. There is no such relationship. These are all independent occurrence. Okay, now if you multiply here, and then if you see just the earlier case we took 1 1, in this case we are just taking r vector as, considering r vector as 1 0. So you see the result is -1 -1. The result is non-zero. Okay. So proving that the fact that AB not equal to C. So in this case, once you change the random vector to 1 0, the A into BR minus CR becomes -1 -1. But earlier it was 0. This one it was 0. But this time it is not. So it is 0 means the multiplication has gone correct. This multiplication is correctly done. I mean, this is AB are equal to CR. The meaning of these results, right? Because if you multiply AB equal to C, so AB minus C should be equal to 0, and then ABR minus CR should also be equal to 0. It has gone correctly. But in this case, just the changing of the random bits, because random bits can be anything, that to 1 bits, you have changed to 1 to 0, and the output you are saying that is not 0. Output should have been 0, but it is not 0. That means there is slight possibility that after introducing randomness as a random vector, the output may go wrong. That means AB not equal to C. That means ABR not equal to CR. So the result is non-zero, proving that fact that AB not equal to C. So there are 4 2 element 0 1 vectors, and half of them give the 0 vectors in this case. Okay, so half of them give the 0 vector, in this case r equal to 0 0 and r equal to 1 0. So the chance of randomly selecting these two trials is 1 by 2 square or 1 by 4. So these are 4 options are there, right? 4 options, which is 1 by 2 square. So the chances so the chance of randomly selecting these two trials, concluding that AB equal to C is 1 by 2 square, AB equal to C is 1 by 2 square or 1 by 4, because there are 4 options, first trial, second trial, third trial, fourth trial, 1 by 4 is the probability. So in the general case, the proportion of R yielding to 0 vector may be less than 1 by 2, and larger the number of trials would be used, rendering the probability of error very small. So that means these bits that randomly we are taking here, bit 1, bit 2, so R1, R2, if you take continuous trials, let's say 1000 trials or 500 trials, then the chance of getting this AB not equal to C will be very less, and in fact it will be less than, it will be very small actually, and then we are going to see that how it's going to happen. So let us, because this introducing this randomness reduces the time complexity from O theta n square and then O n to the power 2.78 to O n square. But by this process we also have induced error. Our random algorithm becomes error prone. So you have to analyze how much error it is. Is this error less or is this error more? Because there is a chance that A into B might not be equal to C. In fact, A into B into R might not be equal to CR in some cases. What are those some cases? If those some cases the probability is very less, then we will say that this is fine, we are fine with that. If the probability is higher side, then we have to ignore that, because the chances of that occurrence will be more, so we have to ignore that algorithm completely. But anyway, that is not going to happen. So let's P equals the probability of error. We claim that A cross B equal to C, then probability is 0, and if A cross B not equal to C, that probability will be very less. In fact, that will be less than half. Okay. So here we can, now you are going to see the let P equals the probability of error, and we claim that if A cross B equal to C, then probability is 0. That means if A cross B equal to C, then probability is 0. If A cross B not equal to C, that chance of A cross B not equal to C is in fact, first of all, A cross B equal to C, that will happen. Okay. So when A cross B equal to C, that this is, yes, this is correctly done, then the chance of error, probability, chance of error, probability of error is 0. There is no error. Correctly you are getting, okay? So when A cross B is equal to C, that means everything is correct, everything is fine, and then probability is, error probability is 0 actually. Above error probability is 0. But when A cross B not equal to C, that time that probability is very less also. That probability is very less. In fact, that probability that A cross B is not equal to C is less than equal to half. That you are going to see. We are claiming that. Okay. Now see how it will happen. So first A cross B equal to C. So probability P is equal to, so if A cross B equal to C, let's say the probability P is equal to, after using the random vector which is BR, so we'll first calculate B into R and minus CR. Okay, so basically AB equal to C, so ABR equal to CR. So basically P, let's say P equal to probability equal to ABR minus CR. This should be, ideally should be equal to 0. Okay, if A into B equal to C. Okay, so you see here A into BR minus CR, and then A cross B R minus CR, and then A cross B minus C. So A cross B minus C, we are case 1, which is A cross B minus C, which is equal to 0, because this says that A cross B minus C equal to 0. So just put it 0 here. So 0 into R equal to 0. So this is regardless of the value of R, since it uses only that A cross B minus C equal to 0. Hence, the probability for error in this case, how much probability of error? No error actually. There is no error. It is correctly replied, correctly answered. So probability of P not equal to 0 is 0. Okay. Okay. So that means this will be the vector P, the vector P not equal to 0, that probability is 0. So error is 0. Okay, error is 0 in this case. So this is the meaning. Now let's say A cross B is not equal to C. So in this case, let D such that D into R equal to P1 cross P2 in Pn to the power T. That means here D is nothing but A cross B minus C. So D is nothing but A cross B minus C. This is my D. With this D, I am just having this one random vector, which is any vector you have. So now this is my D. Okay. So this D, we are calling it Dij. no problem, you can call it dij. This is also again a matrix. This has become a matrix only, this because this will, when you multiply this with r, this will be a matrix, and this will also be a matrix, so it will be matrix. So this is, let us call this a dij. So basically dij means what? Here it will be, sorry, so if you see d correctly, let me write it here. So my d is here, this is a cross b minus c, which is equal to dij, and okay, so this is dij, and this p is nothing but d into r. Okay, now since a cross b, so basically this is something like that, d11 d12 dot 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 d1n, and like that dn1, okay, dnn, okay, this is d, and then this is my r vector, which is again random vector r1 r2 r3. This is a scenario you have now. Okay, so this is p equal to this. Okay, so this is dij, this all this is dij, d12 d13, these are all dij. Now if you see here, a cross b not equal to c, we have some element in d which is non-zero. So now this fellow, if it is a cross b is not equal to c, that means this a cross b not equal to c, that means multiplication has gone wrong. Multiplication has gone wrong. That means multiplication should have been 0. A cross b minus c should have been 0, but it has gone wrong. That means some element in dij is not 0. Okay, I mean some element in dij is actually creating problem. I mean some element, first of all, some element, some random value in the random vector rij, which is bad r, that bad are actually creating problem, and this multiplication, that is d matrix d into this r, this multiplication has gone wrong, and it is no longer equal to 0. That is the case. Now how it will happen? So we have some element in d that is non-zero. So here some element in d which will be non-zero element will be there. Suppose that element dij, which is some element which is in this matrix d. So basically I'll just erase it, so it will be easily understandable. So basically what happens here, this is my d matrix, so we are talking about this one again. Okay, so this is d11 d12 d1n, and then this is dn1, like that dnn. With that I am multiplying my vector r, which is r1 r2 rn. This matrix multiplication has gone wrong. Okay, because here my d is, this is my d matrix, which is nothing but, this d matrix is nothing but a cross b minus c, and this is my r matrix. So now this some dij will be here, so these are dij, which is dij, all element inside the matrix d, which is dij. Some element in the dij will be non-zero, then only this multiplication is not equal to 0, because then only this is happening. Not equal to 0 means multiplication is wrongly done. So by definition of matrix multiplication, let's say p, this one, let's say pi equal to summation dik into rk, and k goes from 1 to n, which is true. Like if you multiply d11 into r1 plus d1, so d11 into r, so basically this is di1. Yeah, so this will d, so this will be di1 into r1, di2 into r2, okay, and then di3 into r3, like that it is going. So basically what is this? This is dij. So this is the whole thing. So finally it will be like, last element will be how much? So last element will be dot dot dot, last element will be din into rn. Okay, so yeah, so this is there. So there will be some di d some dij into rj will be there in this expression. Some dij into some dij into rj will be there in this expression, which is not, which is actually creating problem, which is totally, it is not zero. Okay, which is not zero. So I can write this expression as dij into rj plus y. So that problem creator is nothing but, let's say, 1 dij rj plus the remaining whole expression is a constant expression, let's say, that is nothing but equal to y. Okay, now, okay, now if you see, so that y, so basically it has to be zero, this whole thing has to be zero, this whole thing has to be zero ideally, this whole thing has to be zero ideally. So you see, this whole thing has to be zero, but that is not happening. This whole thing should have been zero, but that is not happening here. Okay, so what exactly, so for some constant y, so this is y, this is y, this whole remaining thing is y. Let's say that the problem creator dij rj is the first element, di1 r1. Okay, it could be the case, or it could be the di2 r2, it could be the case that di3 r, anyone. That is, I am putting it here, we are putting it here in the first expression, and then remaining things will be constant. Okay, so that should have been zero, but that is not zero. So that constant, for some constant y, that the y that we have shown it here, y, this one, this one. Okay, that y, so that y using some constant y, using Bayes theorem we can partition over y. So basically now what we are going to do, we are going to using Bayes theorem we can partition over y. Now what Bayes theorem says, that Bayes theorem says that this is Bayes theorem. Bayes theorem you already know, this is a conditional probability, so this is likelihood, this is likelihood, this is prior probability. Prior probability means there is no condition. Okay, simply direct probability of finding. This is again prior probability, and this is called posterior probability. Posterior probability is the conditional probability. Okay, posterior probability. These are also posterior probability, but that is called likelihood. But anyway, let's see what is happening here. So first we will write it here, that this expression we will write uh, this one dij plus rj. So pi, basically here pi equal to, yeah, pi equal to d pi equal to summation k equal to 1 to n dik into rk, which is equal to di1 r1, like that, dot 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 dij rj, and then dot 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 din rn. Okay, so this is the situation we have now, and then we are calling that this expression is nothing but dij, some dij is a bad dij, and rj plus the remaining thing is constant y. So what is the probability, how this y will behave? Okay, so using Bayes theorem we can partition over y. So probability of pi equal to 0, that this probability of pi equal to 0 equal to probability pi equal to 0 given y is 0. Okay, what is the probability pi will be equal to 0 given that y is 0, this is the first case, times probability of y is 0 plus probability of pi is 0 given that y is not equal to 0, this y is not equal to 0, times probability of py not equal to 0, right? So let's calculate the first one, probability of pi equal to 0 given y equal to 0. So probability of pi equal to 0, so let me take the red So probability of pi equal to 0 when y equal to 0, what has to happen? So basically probability of pi equal to 0 given that y equal to 0, what is the probability? In that case, if this has to be 0, this y has to be 0, and this probability also has to be, that means this dij, this whole component has to be 0. So that means what? That means rj has to be 0. If rj is 0, then only this whole dij into rj will be equal to 0. So this is nothing but probability of rj equal to 0. So what is this probability? This probability rj can take either value 0 or it can take 1. So two options are there, so probability is half. Okay, so first case is done. Second case is that this pi equal to again dij into rj plus y. Now probability of pi equal to 0 and y not equal to 0. This is not equal to 0. Okay, this y. What will be the chance? See, y not equal to 0, but still you want probability as 0, then this thing has to be minus y. Okay, so this component has to be minus y. That means what? That means this dij has to be minus y and rj has to be 1. Then only it will be minus y into 1, that is minus y plus 1. Total it will be 0, even though if y is not equal to 0, then only it is possible. Okay, so basically, so rj has to be 1 here and dij has to be minus 1. So this probability of occurrence, this will only happen very less time, which is even the probability is that rj equal to 1 is very less, which is even less than half. Okay, less than half. Very rare that it will happen, very rare. Okay, so plugging all this thing in equation, we get probability of pi equal to 0, which is less than equal to half into probability y equal to 0 plus half into probability y not equal to 0. So probability of half into 0 is this, y equal to 0 plus half into probability of minus pr y, because this probability of y not equal to 0, I can write 1 minus probability y equal to 0. Okay, so altogether it is half. Therefore that probability p equal to 0, if you take for because this is this value of r is this independent random numbers, r1 r2 independent random numbers. So every time you do trials, let's say you do 1000 time trials, even the probability of getting that abr not equal to abr minus br not equal to 0, that chance even will reduce further. That means probability will be very less. So it will be like probability of p equal to 0, that probability will be in fact less than even half. So that completes the proof. Okay, so you just saw that the simple algorithm analysis shows that the running time of matrix multiplication is two matrices. Multiplication usually is O of n square using this simple algorithm, which is Freivalds algorithm. Using this simple algorithm, the time complexity has reduced considerably, which is O n square. This beats the classical algorithm runtime, which is O n cube in the naive algorithm of matrix multiplication. The error analysis also shows that if the algorithm ran k number of times, that means if number of trials increases, that is what happened in all randomized algorithm. Even in the case of quick sort, randomized quick sort, if you increase the number of trials, we have discussed that. So all randomized algorithm, you have to increase the number of trials, then only it will be validated. So error bound less than 1 by 2 to the power k. That means the probability will be very less that the matrix multiplication results will be wrong. Okay, so the algorithm is also fast in practice due to wide availability of first implication of matrix vector product. Therefore, the use of randomized algorithm can speed up a very slow deterministic algorithm. And Freivalds algorithm frequently arises in introductions to probabilistic algorithms. In all, I mean, if you see the algorithm, probabilistic algorithm syllabus, you will find Freivalds algorithm is always inclusive because of its simplicity and how it illustrates the superiority of the probabilistic algorithm in practice for some problems. Okay, so I hope you understood this concept. Thank you.